Dear students, welcome to another video tutorial on operating system. And today's topic is paging. Myself Niladri Shekhar Pal. I am working as an assistant professor at Greater Kolkata College of Engineering and Management at Computer Science and Engineering Department. The college is under JIS Group Educational Initiative and the college is situated at Barulpur. So what is paging? Paging is nothing but a storage mechanism, that allows us to retrieve processes from the secondary storage into the main memory in the form of pages. So in the paging method, the main memory is basically divided into small fixed size blocks of physical memory, which is called frames. The main idea behind the paging is to divide each process in the form of pages. So the main memory also be divided in the form of frames. The size of a frame should be kept in the same as that of a page to have a maximum utilization of the main memory and to avoid external fragmentation. One page of the process is to be stored in one of the frames in the memory. The pages can be stored at the different locations of the memory, but the priority is always to find the contiguous frames or holes. Paging is used for faster access to data, and it is logical a concept. A computer can address more memory than an amount of physically installed on the system. This extra memory is actually called the virtual memory, and it is a section of a hard that's set up to evaluate, the computer's RAM. Pages of the processes are brought into the main memory, only when they are required. Otherwise, they are resides in the secondary memory. Paging technique plays an important role in implementing virtual memory. Different operating system defines different frame sizes. The sizes of each frame must be equal, considering the fact that the pages are mapped to the frame. In paging, page size needs to be same as frame size. So this is an example of process and paging. So if the main memory size is 16 KB, the main memory will be divided into 16 collection of 16 frames of 1 KB sizes. So this is the main memory. The size of the main memory is 16 kilobyte. So it has been divided into 16 frames. A1, A2, A3, A4. So these 16 frames are each of 1 kilobyte size. There are 4 separate processes in the system. So basically 4 processes are there. One is A1, another one is A2, next one is A3 and A4. So A1, A2, A3 and A4. And each process is divided into 4 parts. So there are 4 separate processes in the system, that is A1, A2, A3 and A4 of 4 KB each. So each process are of size 4 KB, and these 4 KB are distinguished into 4 parts. As you can see here also A3 there are 4 parts, A2 there are also 4 parts, and at A4 there is also 4 parts. Here all the processes are divided into pages of 1 kilobyte, each of size, so that the operating system can store one page in one frame. At the beginning of the process, all the frames remain empty, so that all the pages of the process will get stored in the contiguous way. So at first the main memory was empty. So as you can see that at first process A1 get executed, A1. After that the process A2 will be executed. After that A3 and A4. Okay, so in between of A1, there is no other process came into the main memory. In this example, you can see that A2 and A4 are moved to waiting state after some time. Okay, so A2 and A4. Okay, this is another example. This is A1, 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 A1. This is A2. Okay, so A2 has 4 parts, that is 4 KB. Okay, and 3 KB has already executed, and after that, A3 has come into the scene. Okay, so A3 has been executed for 4 kilobyte. Okay, and after that, A4 has been executed. Okay, so therefore 8 frames becomes empty. So other pages can be loaded in the empty blocks. Okay. So the process A5 of size 8 pages are waiting in the ready queue. Okay. In this example, we can see that there are 8 contiguous frames which is available in the memory, and pages offer the flexibility of storing the processes at different places. Okay. So as you can see that here in this example, A1, A2, A3 and A4 or A5. Okay, so here A2 and A4 is not here. Okay, so here is A5. Okay, so A5 has been executed. Okay, instead of A2 and A4. A2 and A4 is not here. Okay, in the position of A2 and A4, A5 has been executed. Okay, so this is A1. After A1 there was A2, but A5 has been executed in place of A2. Then A3, and then again in case of A4, okay, A5 will be executed. Now, what are the protections that is associated with paging? The paging process should be protected by using the concept of insertion of an additional bit, that is called valid or invalid bit. Okay, paging memory protection is basically a paging that is achieved by associating protection bits with each page. These bits are basically associated with each page table, okay, entry, and specify the protection on the corresponding page. So what are the advantages and disadvantages of paging? Okay, so what are the advantages? So the advantages of using paging method is it is easy to use memory management algorithm. Okay, there is no need of external fragmentation. Swapping is very much easy between equal sized pages and page frames. Okay. What are the disadvantages of paging? It may cause internal fragmentation. Okay. Complex memory management algorithms can be and does not handle in paging. Page tables consumes additional memory. Okay, and multi-level paging leads to memory reference overhead. So what is segmentation? So what is segmentation? Segmentation method works almost similarly to paging. Only difference between the two is that segments are of variable length, whereas in the paging method, pages are always of fixed size. Segmentation is a memory management technique in which each job is divided into several segments, okay, of different sizes, one for each module that contains pieces that related to the functions. Each segment is actually a different logical address space of the program. Okay. A program segment includes the program's main function, data structures, utility functions, etc. Segmentation method works almost similarly to paging. Only difference between the two is that segmentations are of variable length, whereas in the paging method, pages are always of fixed sizes. When a process is to be executed, okay, its corresponding segmentation are loaded into non-contiguous memory, okay, though every segment is loaded into a contiguous block of available memory. A program segment basically includes the program main function, data structures, utility functions, etc. The OS basically maintains a segment map table for all the processes, okay, which is kept with the operating system. It also includes the free memory blocks along with its size, segment number, and its memory locations in the main memory or virtual memory. Okay, so the OS maintains a segment map table for all the processes. Okay, it also includes a list of free memory blocks along with its size, segment number, and its memory locations in the memory or virtual memory. Okay, so what are the advantages and disadvantages of segmentation? So what are the advantages? It basically offers protections within the segments. You can achieve sharing by segments referencing multiple processes. Okay, not offers internal fragmentation. Segmentation tables use lesser memory than paging. Now, what are the disadvantages? Okay, basically, in segmentation method, processes are loaded or removed from the main memory. Okay, therefore, the free small memory spaces is separated into small pieces, okay, which may create a problem of external fragmentation. So, costly memory management algorithm is a disadvantage. Okay, so we can conclude that paging is basically a storage mechanism, okay, that allows operating system to retrieve processes from secondary storage into the main memory in the form of the pages. Okay, and the paging process should be protected by using the concept of insertion of an additional bit called valid or invalid bit. The biggest advantage of paging is that it is easy to use memory management algorithm. Okay, and paging may cause internal fragmentation. Okay, and this segmentation method works almost similarly to paging. Only difference between the two is that segments are of variable length, okay, whereas in the paging method, pages are always of fixed size. We can easily achieve by sharing segments referencing multiple processes. Segmentation is costly memory management algorithm. Okay. Next come why segment we need segmentation. Basically we are using paging as our main memory management technique. Okay. Paging is more close to the operating system rather than the user. Okay. So it is very much concerned about operating system. User has no concern about this paging. It divides all the process into the form of pages. Okay, regardless of the fact that a process can have some relative part functions which needs to be loaded in the same page. Operating system does not care about user's view of the process. Okay. It may divide same functions into different pages and those pages may or may not be loaded at the same time into the memory. Okay, and it also decreases the efficiency of the system. It is better to have segmentation which divides the processes into the segments. Each segment contains same type of functions such as main function which can be included in one segment and the library functions can be included in the other segments. Okay, so what are the process to translate a logical address into a physical address? Basically CPU generates a logical address which contains two parts. One is the segment number and the next one is the offset. Okay, so we can say that the paging is one of the memory management schemes, okay, by which a computer stores and retrieves data from the secondary storage for use in main memory. Okay, So in paging memory management scheme, the operating system retrieves data from secondary storage in same size blocks called pages. Okay. So paging allows physical address space of the process to be non-contiguous. Okay. So paging is to deal with external fragmentation problem. This is to allow the logical address space of a process to be contiguous of a process to be non-contiguous, which makes the process to be allocated physical memory. Logical address space of a process can be non-contiguous. Process is allocated in the physical memory. Okay, so divide physical memory into fixed size blocks, okay, called frames. Divide logical memory into blocks of same size called pages. Keep track of all the frames, okay, and to run a program of size n pages, we need to find n frames and load programs. Okay, so here you can see that the CPU generates a logical address which contains two parts, segment number and offset number. The segment number is mapped to the segment table where the limit of the respective segment is compared with the offset. Okay, and if the offset is less than the limit, then the address is valid, otherwise an error as the address is an invalid. In the case of valid address, the base address of the segment is added to the offset to get the physical address of actual word, okay, in the main memory. So as you can see that how the logical address has been translated into the physical address. Okay, as you can see that these are the base and this is the limit. Okay, so these are the 0, 1, 2, 3. From segment table it will come to the logical address. Okay, CPU also did it. So if the offset is less than the limit, okay, so it will not happen, then it is an invalid address. If offset is less than yes, then it will go to the segment. Okay, so again it will go to the segment 2. So after, in case of 1, it will go to the segment 1. If it is 3, it will go to the segment 3. Okay, so this is the physical address space and this is the segment table and this is the logical address space. Okay, so this is how logical address has been translated into the physical address space. Okay, so as you can see, this is the logical address space. Okay, if the offset is less than the limit, then it will move to the or converted to the physical address space. So we can say that the virtual and physical addresses are the same in compile time and load time address binding schemes. Okay, so virtual and physical addresses differ in execution time address building scheme. Okay, the set of all logical addresses generated by a program is referred to as a logical address space, and the set of all physical addresses corresponding to these logical addresses is referred to as a physical address space. Okay, so the runtime mapping from virtual to physical address is done by the memory management unit or MMU, which is a hardware device. Okay, MMU basically uses the following mechanisms to convert virtual addresses to physical addresses. Okay, so the value in the base register is added to every address, which is treated as offset of the type it is sent to memory. Okay, for example, if the base register value is 10,000, then an attempt by the user to use address location 100 will be dynamically reallocated to the location 10,100. Okay, so 100 has been added with the 10,000. The user program deals with virtual addresses. Okay, as it never sees the real physical addresses. Okay, so the choice between static or dynamic loading is to be made at the time of computer program being developed. If we have to load our program statically, then at the time of compilation, the complete programs will be compiled and linked without leaving any external programs or module. Okay, dependency. The linker combines the object programs with other necessary object modules into an absolute programs, okay, which also includes logical addresses. If we are writing a dynamically loaded program, then our compiler will compile the program and or and for all the modules which we want to include dynamically. Okay, only references will be provided and rest of the work will be done at the time of execution. Okay. So at the long time of loading, the static loading, the absolute program is loaded into memory in order for execution to start. If we are using dynamic loading, okay, dynamic routines of the library are stored on a disk in reallocatable form and are loaded into main memory only when they are needed by the program. So we can say that at last we can say that logical address or virtual address can be defined as an address that is generated by the CPU. Okay, and what is logical address space? It is basically the set of all the logical addresses generated by the program. Now, what is physical address? Physical address is basically available on memory unit. And what is physical address space? The set of all physical addresses corresponding to the logical addresses are called the physical address space. We can see that if logical address is of 31 bit, then logical address space will be 2 to the power 31 words. Okay. If the physical address is 22 bit, then the physical address space will be 2 to the power 22 words. Okay. So the mapping from virtual to physical address is basically done by the memory management unit, okay, which is a hardware device, and this mapping is basically known as paging technique. Okay. So the physical address space is conceptually divided into a number of fixed size blocks called the frames, and the logical address space is divided or splitted into fixed size blocks which is called pages. So we can say that the page size is equal to the frame size. Okay. So if we go, so take an example, suppose physical address is 12 bits, then the physical address space will be 4K words. Okay. And if the logical address is 13 bit, we can say that it is logical address space can be 8 kilowatt words. Okay, and the page size is same as will be the frame size, that is 1K words. Okay, so what is page number? It is basically nothing but the number of bits required to represent the pages in logical address space or page number. And what is page offset? It is number of bits required to represent particular words in a page or page size of logical address space or word number of a page or page offset. Okay, and we can say that the page physical address space is also divided into two parts. One is frame number, one is frame offset. What is frame number? It is nothing but the number of bits, okay, that is required to represent the frames of physical address space or frame number. And what is frame offset? It is basically the number of bits required to represent particular word in a frame or frame size of physical address space, okay, or word number of a frame or frame offset. Okay. Okay. So students, this is all about the paging. Okay. So I think we will be able to understand how we have converted from logical address to physical addresses and how we can do the paging scheme. Okay. So this is all about the paging and logical physical addresses. Okay. In the next tutorial, we will discuss about more regarding the memory. If you have liked my video, you can subscribe my channel, or if you have any doubt, you can mention your doubt in the comment section. Okay, or you can visit www.facebook.com/digitalclassroom Niladrika to get all the details and notification of my tutorial. So students, thank you for now. See you in the next video.